Okay, good day class. We'll continue sa atong discussion on electrostatics. So previously, atong discussion is about calculating the electric field, and we have also calculating the electric potential. Okay, so previously atong gidiscuss kay kana we have calculations so recall ato ang focus sa previous discussion kay more on electric force. We also have electric potential, electric field. Okay, what else? So yeah, I think nag-revolve siya around this one. And there are many ways wherein we can derive the electric force, electric potential, and electric field. Okay, so pwede tayo magamit atong different kinds of formulas given the charge density. Okay, by virtue of the differential Gauss's law or the integral Gauss's law. For the differential Gauss's law, we have the Poisson, right? So we have this one, rho over epsilon naught. And for the integral Gauss's law, we have E dot dA equals Q enclosed over epsilon naught. Okay. Where the electric field is given by this formula, the general formula for the electric field, we have rho d tau, we have r squared, r hat. Okay, and then for the electric potential, we have this formula. That's rho d tau r. So it's a scalar quantity. Now we look into the calculation or determine the work and energy in electrostatics. So kaning duha ka terms, we have work and energy. These are all familiar sa inyo ha, because you've been exposed or you've been using or you've encountered already the work and energy even in your elementary years, high school years, and even pag abot sa inyo sa college wherein nag-take mo og university physics. And in reality, work and energy are all present in different kinds of systems when we study physical phenomena. Okay, so these are fundamental nga mga quantity that we need to understand and consider. Okay, so when we define what are work and energy, okay, so these terms somehow ma-use siya interchangeably, but actually they are different. They have similarities, but they are of different entity and different iyang definition and the governing equations as well. Okay, so you already know sa previous ninyo nga discussions that work is defined as the yung formula is work is F times D. So there is work if there is force and there is displacement, and also the direction of the displacement and the force should not be perpendicular to each other, otherwise there would be no work. So work is zero if that's the case. Energy has no particular equation depending on what kind of energy. So we have different equations depending on what kind of energy. Okay, it could be potential energy. Okay, example, it could be potential, it could be kinetic, it could be chemical, it could be atomic, and so on. So dalahi ang iyang equation. Also, both of these quantities kay scalar. So it doesn't depend on directions. And work is, as I've said, it's the ability to supply force and a change in distance of the object given by this. Okay, so also energy is defined as the capacity to do work. Okay, or energy is just the result of the work performed. Okay, so there is work because naa kay energy. Okay, so there is no work if wala energy, of course. How can you perform something if there's no energy present in the first place? So that's how uh, these two differ and share some similarities. So we will apply these concepts in the concept of electrostatics, I mean. Okay, so if work and energy are applied in classical mechanics, we have a ball rolling down the hill, you have a baseball bat, you have a human running. Those things that I mentioned have work and energy. We can also apply the same concept, meaning we can calculate the work and energy when we talk about charges such as electrons and protons. Okay, so yeah. So in order for us to understand and calculate work and energy in electrostatics, let us consider a point charge Q1 at the origin. Okay, so if you have, say this is 3D, you have x, y, and z axis in Cartesian coordinates. If we have a charge at the origin, so it must look like this. So it is situated at the origin. So this is Q1, okay, located at the origin. Now we will assume, okay, na naay charge Q2 that is moved from infinity to a distance R2. Okay, so let's say, so if you go to the next page, okay, so we have a point charge Q2 is moved from infinity to a distance R2 from the origin. So we will assume that the point charge Q1 remains fixed at the origin while the point charge Q2 is moved. So if you have your Q1, so this is at the origin, say mo na ako ang coordinates. And if I have Q2, okay, so if I have Q2, say this is from infinity nga distance, gimove na ko siya. Okay? At a distance, gimove na ko siya diri at a distance padulong diha. So na diri ang Q2. And this is a distance this. R2. So muna yung distance ni R2. So we will assume that the point charge Q1 remains fixed at the origin while the point charge Q2 is moved. So wala na nag-move ang Q1. We can calculate the force exerted by Q1 on Q2 since both are positive. Let's say this is positive, kani positive na siya, this is positive. And we know na two charges of the same two particle of the same charge, okay? Kaya mo repel na siya, yung charge sign mo repel. So if mo repel na siya, so naa siya force actually nga gi-exert ang charge Q1 onto charge Q2 as you try to move Q2 from infinity to a certain distance R sub 2. So unsa kay ang equation ana? What is the force exerted by Q1 onto charge Q2? So we might write force exerted by charge Q1 on charge Q2 is given by, di ba ana naman ito nga formula? Katong Coulomb's law. Okay, so we have charge Q1, charge Q2 over, say, R2 squared. Okay, and this is R hat. So yeah. Or we can just simply say F12 equals Q1 E2. Oh, I mean, E1. Oh, I mean, baliktad. Let's say we have this one. So we'll write first Q2, then we have E1. Okay, so pwede siya ana. Where kani siya, and including this one, we have E1. So that is the charge, what do you mean? The electric field caused by charge Q1. Okay, so we have this formula F12 equals Q2 E1. So it's basically kani siya. So we can calculate the force exerted by Q1 on Q2, which is equal to this one. Okay. So as I've said, where E1 is the electric field generated by Q1. Now, in order for the charge, in order to move charge Q2, we will have to exert a force opposite to this one. Okay. So, you have Q1 and we have Q2. It's like na force nga na mag-repel siya ana. Okay. So this is F12. So this is F21. Okay. So therefore, we can actually calculate the total work that must be done to move Q2 from infinity to R2, which is equal to this. Okay, I hope naka-recall mo ana. That's the katong line integral. Okay, this is the definition of work. Work is just force times distance. But since ang displacement niya nga direction or ang iyang path nga giagian is not straight line anymore, then we can convert this to F times dl. So it becomes an integral, right? Where the line integral ang giagian sa charge Q2, it is from infinity to charge to distance R2, muna yung limits niya. Okay, so then this is the force exerted by charge Q1 onto charge Q2. Okay, where F12 is given by this. So substitute mo siya diha, you get this. Okay, and if you take a closer look, kani siya nga definition, ay kani siya nga entity, E2.dl. This is the definition of the potential, right? And this is E1, E1.dl. So that is the definition of the potential. That's why we have that. So potential is just the line integral EdL. Okay. So I just rewrote the equation. So from equation 43, so using this equation of V for a point charge, the work W can be rewritten as this one. Okay. So we now have this one, wherein ang kaning V1, that's 1 over 4 pi epsilon naught Q1 over R2. Okay? Then mo siya i-substitute diha, you get this expression sa imong work. Okay? So, recall ta sa W gani, that's the work needed to bring charge Q2. So this is distance R2 from infinity. Gikan siya sa infinity, imo siyang gidala diha padulong din nga distance, which is distance R2. So the work needed for you to bring charge Q2 from infinity to a distance R2 is given by this expression. That's given in equation 44. Okay? So the work W is the work necessary to assemble a system of 2-point charges. That is what we call the electrostatic potential energy. So it's like nag-assemble ka og system nga we have charge Q1 and then charge Q2. So gisa nimo siya pag-assemble. Of course, nasugod ka og Q1 gibutang nimo sa origin. Then sunod nagdala ka og charge Q2 from infinity up to this particular distance. We have this assemble. I-assemble nimo ang duha ka charge. And the end or the work needed or work necessary nga amount of work necessary to assemble that system is given by this expression. Okay? So the energy of a system of more than 2-point charges can be found in a similar manner using the superposition principle. Katong kaganina is kanisiya, this is for 2 charge from Q1 and Q2. This is a distance R2. How about for 3 charge system? So the same principle applies. So you have this assemble nga system. So ang pagporma nimo ana is na-start ka og let's say Q1, then gikan sa infinity gikuha nimo ang Q2, imo siyang gibutang dinha na siya distance nga R12. Then ikuha na pa ka another charge from infinity, gibutang nimo sa kaning distance, and that's distance R13, or this is R23. Okay, that's why we have this kanisiya. Okay, and the work needed para ma-assemble na siya nga system, still we can use the same principle that we did kaganina, which is given by this expression. We have 45, right? Okay, so this is for charge Q1, Q2. This is for charge Q1, Q3, and charge Q2, Q3. So this is the total work needed para ma-assemble nimo siya. This is the total work needed para ma-assemble nimo ang tulo ka charge into this particular orientation. Okay? So in general, we can go beyond 3 charges. How about for 4 charges, 5 charges, we have 6 charges, and even more than 6. Let's say we have many charges. Okay, i-assemble nimo in this particular nga system. Okay, daghan ka na say pila ni kabok. Let's say 50 kabok charges. How about 100? Okay, we can generalize our equation, meaning can we get the total work needed to assemble such many particles? So that is given by using equation 46. So if you take a look, it's the same formula sa kanisiya, equation 45. So we have Q1, Q2, Q1, Q3, Q2, Q3. If upat na siya ka charges, so naana po kay Q1, so kung mausap na po din siya if upat ka charges, we have Q1, Q2, Q1, Q3, Q1, Q4, and so on. So in general, you can have this equation. Okay, so take a look at the sum. So this is I equals 1 up to n. This is I equals 1 up to n. And this is j equals I plus 1. Oh. J equals I plus 1. So meaning ang I should not be equal to j, which makes sense. Okay? Okay, if you have, let's say, 5 charges, wala naman ka Q1, Q2 over R1, R2 plus Q1, Q3, Q1, Q2, Q1, Q3, I mean, R3 plus Q1, Q4, R1, 4 plus Q1, Q5, R1, 5. So, take a look at the index. So, good kag 1, I equals 1. For I equals 2, so napugay plus Q2, Q3, R2, 3 plus Q2, Q4, R2, 4, and so on. Okay, that's for 5 charges lang na. For arbitrary n, we get this formula. So we have the lower limit ensures that each pair of point charges is only counted once. Okay? So the electrostatic potential energy can also be written as, para ma-simplify na siya, can also be written by this expression. So pareha na siya. Pareha. So take a look at this one. Instead na magsugod og I plus 1, nagsugod siya diri I equals 1, where I should not be equal to J. Okay? Or, pwede siya, we have this one, i-simplify na siya, i-rearrange. Take a look na ako yung 1/2 din nga factor because na may magbalik-balik ana, di ba? Count man niya ang Q1 o Q2 o Q2, Q1. Unlike kani nga wala siya nagbalik-balik. Pero kani siya nga expression kani sa ubos, gi-count niya og kaduha Q1, Q2 separate pero dapat dili siya. That's why na I 1/2 din hi para ma-offset ang katong nanubra og count. Okay? So from this expression, you can rearrange that one. Butang nimo ang QI din hi and your QJ over RJ din ha, because that looks familiar, because this expression is actually the definition of the potential. Okay? Potential VI. So, mabalik ka sa previous na ito discussion, this is the equation for the potential. So, ang kanina expression, ma-simplify siya into just using this form, meaning the work needed to assemble n number of charges is just equal to 1/2 the summation of QIVI, where I runs from 1 up to n. Okay? So this is the equation, we just rewrote it. So when the charge of the system is not distributed as point charges, okay, kani siya for discrete man siya. For discrete system, meaning charge is distributed as point charges. This is actually system is distributed as point charges. Okay? So what about systems nga continuous? Okay, because in reality na ba dili kakita og system nga discrete. We can always find systems of continuous nga system. For example, we have a metal rod, a metal ball, a spherical or cylindrical nga mga type of objects. Those are continuous, meaning ang yang electrons, okay, is like spread out in a particular region na continuous siya, wala siya, dili siya point charge ang iyahang distribution. Okay? So we have this, but rather as continuous instead na point charge distribution. So we have your rho, which is the charge density or the volume charge density. Then the electrostatic potential of the system must be written as this one. So this is the electrostatic so this is electrostatic potential, okay, or potential energy given by this. So from summation it becomes this one, right? Meaning ang imong summation becomes an integral and ang imuhang QI it becomes continuous. So we have rho d tau. Okay? That's why nakakuha ng equation 48. So this is for volume. How about for surface and line charges? So the electrostatic potential energy is equal to this one, equation 49, and equation 50. So similar na siya, ang nag-differ lang is kana. Okay? So this is for continuous system, this is for discrete. Okay, or point charge distribution. Kani siya for continuous charge distribution. So we can also relate or see that the charge density rho is related to the electric field E. Di ba naman tayo ng equation before? Meaning, ang relationship between electric field and the charge density. Okay, it's given by this one. Del dot E equals rho over epsilon naught. So this is the differential form for Gauss's law. Right? So that's the differential form of Gauss's law. Then we can get the rho is equal to epsilon naught del dot E. Okay? So that's why we have this equation. So we can use this relation to rewrite the electrostatic potential energy as, okay, so katong electrostatic potential energy, di ba ana man to? W equals 1/2 so ito we have balikta this one rho v d tau. Okay, this rho v d tau, right, where rho is given by this. That's why nakakuha ng equation. And what you call this? Imuha siyang from this equation, naabot siya ana because of product rule. Okay, so we have del dot E v d tau is also given by del dot v e d tau minus E naught over 2 epsilon naught over 2 integral. We have this expression E dot del v. Okay, so from this expression we get this equation na sa kaning last, i-simplify lang na siya. And also from this equation we can see nga kaning first term is 0 or it approaches to 0, because if you try to enlarge your system, say ang Gauss's law mo siyang i-enlarge na siya din na becomes very large, the tendency is this one ang kaning second term mo increase, but this should go to 0, otherwise ang imong total energy would not be equal anymore. Okay, so conserve man ang imong total electrostatic potential energy. Okay, so your E dot dA will now approach to 0, so ang mo dominate na term is your second term, which is given by this. Okay, so we have this one. So as I've said, the first term approaches 0, leaving us with the second term only. So muna siya ang mo dominate. Okay, while the first term vanishes. So our final form sa to ang electrostatic potential energy is given by equation 51. Okay. So this is another form of potential energy. Okay, na the other form is katumang W equals 1/2 rho v d tau. Pareha na sila. Okay, patlahi lang siya og form. This one makes use of the electric field ang kaning siyang right hand side, while the left hand side makes use of the V or the potential. Okay, let's take a look at this example. So we have a sphere of radius r carries a charge density rho of r equals kr, where k is a constant. So find the energy of the configuration. You might check your answer by calculating it in two different ways. Okay, so if you want to find the energy configuration, we are looking for W. And there are two ways para ma-solve natin na siya. We have 1/2. You can use the 1/2 katong kani siyang expression. E naught ano siya? Over 2 kana E squared d tau, tama. Okay. And the other one is 1/2 rho v d tau. So we should be able to get the same answer. Pero lahi atong gamiton nga method. Okay, so we'll make use of this equation first and then this equation. So para ma-check ang atong answer, they should both give the same answer or result. Okay, so let's take a look at method 1. We will use this expression. Okay, so the electric field can be defined by using Gauss's law. So we can determine E using Gauss's law. So unsa kani siya nga system? This is a system of a sphere of radius r. Okay, this is a sphere of radius r. Radius r. Ay dako nga r, I mean. So that's a sphere of radius r. So unsa ka ang iyahang kuan ni electric field? Okay? So we can get the electric field both inside and outside. So unsa iyang electric field inside, unsa iyang electric field outside. Okay? So using Gauss's law, so ito siya. Let's say if you want to calculate the electric field using Gauss's law, make use of the formula E dot dA equals Q enclosed over epsilon naught. Okay, for ano na lang, para consistency, we have Q enclosed. Okay, Q enclosed epsilon naught. So we can calculate the electric field inside. Tuloy balahin din. So what is the electric field inside? Electric field. Okay. So electric field inside is actually using Gauss's law. We have E times your dA. Unsa man imong ani Gaussian surface. Okay, so we have this one. This is our Gaussian surface. Yeah. Okay. So this is radius r. And what is the para mas klaro. So this is your Gaussian surface. Because we are considering electric field inside. Okay? Take note, sphere na siya, spherical. So, what to do next? So we need to determine the surface area of that Gaussian surface. We have dA or A. Okay? So it's given by 4 pi r squared. That's the surface area sa sphere. Okay? With radius small r. This is equal to, okay, so we have integral of rho of r d tau over epsilon naught. So this is your Q enclosed. Ang Q enclosed is integral of rho r d tau. Right? Take a look at this one. Ang imuhang charge kay kr man na siya. Okay? So imuha na siyang integrate. We have integral of kr. Ang d tau nimo is r squared sin theta. Hindi mo siya maigo. Ha? You have integral of r squared. Oh, sorry. This is kr. Then we have r squared sin theta dr d theta dphi. Okay? So, turo na siya ka-integral ha. Triple integral. This is 0 to r. 0 to ang theta nimo is 0 to 2 pi. Ang phi nimo is 0 to pi. Na. So, if you integrate that one, that's actually integrating. So, take note nga ang 0 to pi o 0 to 2 pi sin theta d theta d phi is just it's just 2 pi. Okay? So technically we have 2 pi integral of k r cubed dr. So I hope naka-follow mo ha. If wala, then you can just pause this video and try to follow sa calculation. Okay, so if imuha na siyang integrate, we have 2 pi k r to the, this is from 0 to r to the 4 over 4. Right? So this becomes pi k r to the 4th over 2. Right? So, imo na siya i-substitute din Imo na siya ang result. So, that becomes this one, where e 4 pi r squared is equal to 1 over epsilon naught pi k r to the 4th over 2. Okay? So, I hope na wala na ko yung namali din nga ang calculation. Na ay one minor correction lang. So, this is actually 4 pi. This is 4 pi. So, this is 4 pi. This is 4 pi. So, this is actually pi k r to the 4th. So, wala na siya. So, this is now equal to So, para ma-simplify na ito, medyo gubot na siya din yung lapita. But anyway, lang siya. We'll try to squeeze in sa small nga space. So, the electric field is now, okay, take note nga na mag-cancel ani. Cancel ang pi, right? R squared cancel, so this becomes 2. So, ang mahang equation becomes E equals kr squared over 4 epsilon naught. So that's the final equation for the electric field. Okay? So that's for the electric field inside. So this is electric field inside. Then later we'll calculate electric field outside. So, muna siya ang solution. So, we have this one. Right? So, that's kr squared over 4 epsilon naught. How about for the field outside? Okay? So, if we draw again the sphere, ano naman na siya? This is your ano siya ang sphere, di ba? So, this is of radius r. And we will draw a Gaussian surface outside. We have this. Okay, that's the Gaussian surface outside. Lahat na lang para lahat na color para mas klaro siya. Okay? So that is small r. So this is your Gaussian surface. Gaussian surface. So calculating the electric field using Gauss's law, ana gihapon siya, E times the area sa imong Gaussian surface, which is 4 pi r squared, equals, so kato gihapong Q enclosed, where Q enclosed is just atong solution. Tara. Q enclosed is pi k r to the fourth. Okay? So but this time around, ang Q enclosed is the whole blue nga line, blue nga circle, right? So which is K pi big R na siya, R to the fourth. Okay? I hope naka-follow na mo over epsilon na. So mag-cancel na siya ang pi na. So we are left with equals K R to the fourth over 4 epsilon naught R squared. Okay, so that's your electric field outside. Okay, so this is for the electric field outside the sphere. Now, kailangan naman ng electric field inside and outside because we want to get the electrostatic potential for the system for the sphere. Okay, because when we try to calculate the total electrostatic energy, we will have this one. So using katong formula na to, W equals 1 epsilon naught over 2. That's E squared d tau. And take note, kaning E din ha, that includes outside ng electric field plus inside. Okay, so that's why ma-break down na siya into two region. Okay, so we have epsilon over 2. Okay, and we'll have kana E squared. This is let's say inside d tau plus epsilon naught over 2 E squared outside d tau. Okay, so muna siya mahitabo. So we'll have this one. Okay, so muna siya. This is inside. So this would be inside and this would be outside. Okay, so the E is kaning E din he. This is for the electric field inside, this is for the electric field outside. And imo na siyang E squared, that's because that's E squared. And ang limit niya sa inside is because it's from 0 to capital R. And sa outside, okay, sayop na siya din. Ang notation lang niya. So this is R padulong infinity. Okay, so that's R to infinity. Next, is mo na siyang integrate. Okay, so you try to solve this on your own and try to see if makuha na din siya nga calculation, ang iyang details niya ba, ang detailed niya nga calculation. So that's why we have this equation na. Okay, we have R to the 6. And then we have also this. So I hope clear na siya. Right? So, kani siya, nagkibaylo lang siya. So we have R to infinity sakto na siya. We have R to infinity. Wala. Sakto na. Okay. And if you integrate this one, you simplify this equation, we get this. And ultimately, we are left with this expression. Okay? So, remember sa kanina, i-remember niyo nga expression. Okay? Dapat the same o form atong makuha sa katong using lahi nga formula. So, this is the electrostatic potential energy. Okay? So, this is for method 1. How about for method 2? So, alternative way of doing it. We get kani siya nga formula. So, instead na electric field atong pangitaon, we will try to calculate potential. So, unsa ang potential? Okay? So, unsa ang potential sa kanina case? So, where do we get V? From the inside of the sphere. So, the formula is given by this line integral from infinity to R. Then, i-break down din nato siya into duha ka regions. From infinity to R, that is outside. So, this is outside the sphere. And from R to small r, so this is inside the sphere. And if you integrate that one, you get this. So, kailangan ma-practice ninyo siya ha. You try to integrate this one. You calculate this, you should be able to get this. Okay? Para na makagain mo og confidence ba nga, kabalo ko saan siya pag-solve. Anyway, na may result. Just have to confirm this one. So, the electrostatic potential energy of the system is thus equal to, mo siyang i-substitute ang V, right? This is your V, mo siyang i-substitute din ha. Okay? And you begin integrating. So, I'll just leave this to you as an exercise na if pag inyo siyang integrate, kani siya should be able to get this, and simplifying, you get this one. So, if mo siyang i-compare kani siya, this is for method 2, and comparing that one to the result we got when using method 1 is actually one and the same. Because pareha sila nga electrostatic potential energy, lahi lang ang ihang method o ihang way of solving it. Okay, so somehow we were able to test our result nga sakto siya. Okay? So it is equal to the energy calculated using method 1. Okay, so we have also another type of material nga to ang mastudihan sa electromagnetism. We also have, aside from katong mga neutral nga mga objects, spherical shell, we have metal sphere, and so on. But we also have metallic conductors. So these are present in your electrical wires. Those are metallic conductors. And those are made up of typically copper man na siya, right? And consider siya as metallic conductors because ang iyang excess charge is nag-lie on the surface sa imuhang metallic object or conductors. Okay? So in a metallic conductor, one or more electrons per atom are free to move around through the material. That's why perfect siya para imo ang material para maka-conduct ka og electricity because it has free electrons nga maka-move around. Metallic conductors also have the following properties. Okay, so the electric field inside the conductor is equal to 0 because wala man kay charge inside because all the excess charges are located on the surface. Okay, so if you have no charge inside, or meaning the net charge is 0 inside, then wala ka electric field. So all the excess charges or the net charge lies on the surface. So you only have electric field outside sa imuhang metallic conductor. Okay, so example, magdraw ka og metallic conductor. Say if you have this one, your metallic conductor. So if you have your Gaussian surface, so inside, so inside the metallic conductor, okay, your electric field oh, electric field 0 inside, but outside nanakay electric field. So outside nanakay electric field. Okay, it's not 0 anymore because the net charge lies on the surface. So nadira ang mga net charge, positive, or negative. Okay? The electrostatic potential V is constant through the conductor. Okay, constant siya through the conductor. Yung potential, we have equipotential. Okay? And the electric field perpendicular to the surface, and the electric field is perpendicular to the surface just outside the conductor. Okay, example, consider the following scenario. We have a spherical conducting shell. Suppose we place a point charge Q, and we place a point charge Q at the center of the spherical conducting shell. It will attract negative charge to the inner surface of the conductor. How much induced charge will accumulate here? Okay, so we have your graphical representation. Okay, then for letter B, for number 2, find the electric field and potential as a function of R in 3 regions. So you have R less than A for R greater than A greater than less than B, and R greater than B, meaning this is inside, this is in between, and outside. Okay, so this is radius A and radius B. Okay, so what is the electric field inside? Okay, so if tanaw na to ang iyahang condition, it will attract negative charge to the inner surface of the conductor. Okay, so if we have sama na siya, we have nakoy positive diha, so na siya negative din, right? Oh, so balik. So we have, so it will attract, this is positive man, and this is charge Q positive. Okay, so it will attract negative charge on this surface, right? Okay, so what is the electric field for R less than A, meaning sa sulod? Kaya siya. So we'll draw the Gaussian surface. So this is the Gaussian surface. Kana. Okay. Lahat lang ang color para dili siya libog. Can make use of, let's say, yellow. So this is the Gaussian surface for R less than A. Kana. And what is the electric field sa sulod? So we can just simply calculate it as 1/4 pi epsilon naught, and charge enclosed niya is Q over R squared. Okay, that's the electric field inside. How about katong sa in between? So okay, for R greater than A less than B. So, kanang sa in between. So asa unsa iyang Gaussian surface ana. So let's try to draw. So this is the Gaussian surface in between. Kana. It's the Gaussian surface. So the electric field inside unsa man? Take a look at the Q enclosed. We have positive and negative. So mag-add up na siya, it becomes 0. Okay? So we can conclude nga ang electric field dinha dapita is 0. Okay? How about for electric field R greater than B? Means sa gawas na gid siya. Okay? So the electric field is then the same gihapon sa katong sa inside 1 over 4 pi epsilon naught Q over R squared. Okay? So given by this equation, so this is R greater than B. We have the three regions. Okay, so the electric field inside the conductor is 0, which is a property of the conductors. Okay, so we have what properties of conductors. Then we can calculate the potential V at these three different regions, because once we have your potential, once we have your electric field, you can get your potential. Katong V del dot E, or not this one. Ano siya nga formula? Katong V equals katong line integral E dot dl, right? Next is your capacitor, another circuit element maybe. Ato ang nga ginagamit sa imong circuitry. We have metallic conductor, then we also have capacitor. So you know unsa man ang capacitor, right? Makita man na sa inyong circuit when you open your CPU, na mga parts din ha, and one of which nga makita ninyo ang itsura kay mo siya ingon ani, or sahay na iya itsura kanang mo siya ana siya, like that's the shape of the capacitor. But what does a capacitor do? Okay, so the capacitor actually is a device or electrical element that stores electrical energy. And ang application aning capacitor is daghan. It acts like a battery. It acts like a small supply of energy, and also application niya is kanang sa mga touchscreen ng mga technology. Okay, ginagamit po siya sa kanang mga condenser microphone, the concept on capacitance or capacitor, and so on, etc., and many more. Okay, because touchscreen man good, your touchscreen acts like a capacitor, because ang itsura sa capacitor is just this one. It's like sa maklaro. Capacitor in simple terms are charges nga giseparate siya by a distance. So if you have a plane, okay, if you have this particular plane, so ma-separate siya into that one. Okay, so we have a plane of charge Q. Okay, sorry. You have plus Q din ha, and sa opposite negative Q. and separated by a distance d. So this is now a simple capacitor. You have positive Q and negative Q. So it really acts like a battery. Okay. So sa touchscreen ninyo sa cellphone, yung ani siya. So you have this one. The moment nga i-touch nimo ang imong finger sa screen, it actually changes the capacitance at that particular location, which sends a signal sa imong smartphone nga you are actually touching that location, particular location sa imong touchscreen. That's why ma-detect niya nga ni-touch ka. So it could be na-touch ka on that particular icon, nag-increase pa ka ang volume, nag-touch pa ka on a certain let's say you are playing, so that particular point nga imong i-touch ang screen, so na siya something na gibuhat sa kanang imong application o sa imong game sa imong phone. Okay, so it's like a sensor. So in most fundamental terms, capacitors are just, as what I've said kanina, kaning duha ka charge separated by a particular or a certain distance d. And we can calculate the potential difference between them, which is given by equation 52. Okay? Meaning na ako'y potential sa taas, na ako'y potential sa ubos. So we have a potential difference. Okay? We have higher potential sa taas and lower potential sa ubos. And we can calculate the potential difference by just taking the difference. Okay? That's why na ako'y V plus and V minus. And it's given by this expression where the potential is just the line integral of electric field that with dl. Okay. So from this, we know that the electric field is proportional to Q, which is given by 53. Yan. And E is proportional to Q and V. So the constant of proportionality is called the capacitance. Okay. So we have your capacitance, which is just Q over V. Okay. Where C is capacitance, Q is charge, V is your potential, electric potential. Do not be confused with W, which is electric potential energy. Okay, so we have this one. Okay. So, wala ko nabutang ang question ani. So, ano na ni siya? The question ani is, let me check. So, ang question niya is kani, find the capacitance of two concentric spherical metal shells with radii A and B. Okay? So, ang iyang graphical representation ana would actually look like this. You have sphere, you have sphere nga kani, this is radii A and this is radius B. Okay, so this is radius A and this is radius B. So, unsa ka ang iyahang capacitance ani? Now, let's say this is plus Q. So, this is plus Q and negative Q ang sa outer nga spherical shell. So, unsa ka ang iyahang capacitance? Okay. So, first we need to determine the electric field. in between the sphere, which is given by this expression. That is by using Gauss's law. Okay, so that's the formula, that's the electric field. Okay, ang imong Gauss's law is kani siya, in between. This is your Gauss's law. Oops, that one. That's your Gauss's law. Gauss's law, Gaussian surface. Using Gauss's law, the electric field is given by this. Okay? So the potential difference between them is kanilang equation gamiton. Right? That's between A and B. We get this one. Substitute mo electric field here. And just simply integrate, you get this one. Okay? So, kamo na'y bahala og solve ha. You try to solve this one. You try this on your own para mas ma-understand ninyo na siya. From this, naabot siya ani nga equation. Okay, that's just simply integrating naman. So, it is clear here that V is proportional to Q. So, the capacitance is therefore, so C is just Q over V. Which is equal to this one. AB over B minus A. You simplify lang siya. So, naman siya Q din eh. So, mag-cancel. We have this one. That's your final form. Okay? Then, another question is, how much work is required to charge up a capacitor to a final amount Q? So, this is like the idea of charging a capacitor or battery. Just basically transferring the electron from one place to another. So if you have, let's say, nakoy ano siya diha, duha ka plates. So i-transfer nimo ang electron from here to that plate. Okay? Once na ma-transfer tanan, then your battery or capacitor is now fully charged. Okay? And basically, what's the work needed para ma-transfer tanan electrons from one place to another? Okay? So that's what we will calculate. Basically, mo man ang idea sa battery. You need some kind of work para i-transfer nimo ang electron from one side to the other side. So in order for you to do that, you need to supply volts, okay, or voltage or potential difference. The same thing is true sa capacitor pag charge nimo siya. So charging is done by pulling the electrons from the positive and carry them to the negative plate. Okay. Suppose that at some intermediate stage in the process, the charge on the positive plate is Q, so that the potential difference is Q over C, from the formula nga C equals Q over V. Okay, so the potential difference is just Q over C. So thus, the amount of work you must do to transport the next piece of charge Q is given by this expression. Okay? I hope clear na siya. Okay? Then we have this one. So the total work necessary to go from zero charge to total charge Q, capital Q, is given by this. Mo siya integrate. Right? So you must integrate with respect to dq, you get this one. So this is the total work needed sa imong capacitance or capacitor. Okay? Since Q is equal to CV, simplify siya, you'll get this expression. Okay? Q is just CV. So, ang form sa imong work needed to charge capacitor is given by this expression, or kani siya. If you have potential and capacitance, or if you have charge and capacitance, you'll use this one. Another example. So find the capacitance per unit length of two coaxial metal cylindrical tubes from die A and B. Kung kanina is spherical man to, diba? Spherical shell. This one is cylindrical tubes. Okay, so the solution is given by this. You need to calculate the electric field. So for you to calculate the electric field, you need to use Gauss's law. And so from the Gauss's law, you need to establish ang iyahang Gaussian surface. Now for this case, ang Gaussian surface is naadiri na kita in between. Okay. Right, so this is the Gaussian surface. Oops. So this is the Gaussian surface. No. And this is distance S, small s. Okay, so 2 pi SL is your surface area sa Gaussian surface. And the Q enclosed is just positive Q. Okay, such that the electric field is given by this expression. Once na naka-electric field, you can easily get the potential difference. So that's VB minus VA. So you get this formula sa potential difference, just the line integral of the electric field from going from point A to point B. So you get this expression. Taking the integral of 1 over S, just ln. Then you get ln of A over B. Okay? So in this setup, you get the potential difference. So A is at a higher potential because ang A is positive man, ang the outer cylindrical tube is negative. So you get this expression. That's your potential. So to find the capacitance, you have to, that's Q over V. Okay? So if you have Q over V, this is Q over, ang potential nimo is Q over 2 pi epsilon naught L ln of B over A. So cancel ang Q, you are just left with this. So from that, you get this expression. That's your capacitance per unit length. Okay? So feel free to pause the video and try to do the calculation on your own. Okay, para makuha ninyo siya. Of course, para makagain mo confidence in that process. Okay? So, kana na siya. That would be all sa kaning topic na to on electrostatics. Part 1 pa lang ni siya. So, next discussion na to will be focusing on differential equation or different methods para pag-solve sa ato ang potential. We have the methods of images and separation of variables as well. Okay, I hope we will still have time. We still have time para maka-discuss ta ana. And after this lesson or lecture na ko, I'll be uploading your next problem set, and please be reminded sa mga deadlines. If wala pa mo ka buhat sa inyong mga uban problem set, please do it now, as early as now, para napamoy daghang time, because you cannot just do all problem sets at once. You cannot just simply do it overnight. So hinahinay rin yung solve. Anyway, ang deadline aning mga problem set is I will move this I will move the submission during the final exam. That would be on December 9. Okay, so that would be all for our discussion for this session. Thank you and stay safe.